Dear viewers, in the previous lecture on the discussion on sulfate, phosphate and borate, we had taken up the sulfate radical only. In this discussion, I'll be taking up in this lecture the chemistry of the conformation of phosphate and borate radicals. I hope you will easily understand these radicals in the form of these two lectures, the chemistry behind the conformation of sulfate, phosphate and borate radicals. Well, let's now discuss the chemistry behind the tests of phosphate and borate. In this connection, first common test is calcium chloride test. In this case, what we do is we take the soda extract and acidify it with dilute acetic acid, heat a little so as to decompose the undecomposed carbonates, followed by the addition of about half a milliliter of calcium chloride solution in water. We'll get white precipitate, and this white precipitate will be due to phosphate, borate, arsenite and arsenate radicals. As I mentioned earlier, that we'll not be discussing the arsenite and arsenate radicals. So we'll be limiting our discussion only to the tests and the chemistry behind phosphate and borate. Now let's discuss the chemistry of the tests and the further discussion on phosphate and borate radicals one by one. Now phosphate. First test for this is silver nitrate test. In this case, what we do, we neutralize the soda extract with acetic acid, and to this neutralized soda extract we add silver nitrate solution. Now suppose we have got phosphate which will be present as sodium phosphate in soda extract, then we add silver nitrate to it. We will be getting the formation of Ag3PO4 plus 3NaNO3, and this silver phosphate has yellow color, so we will be getting yellow PPT. So test is that to the neutralized silver nitrate with acetic acid, neutralized soda extract with the acetic acid, we add silver nitrate, and if we get yellow precipitate, it indicates that this phosphate is present. This yellow precipitate is soluble in ammonium hydroxide as well as in HNO3 also. If we want to dissolve in HNO3, then it will be Ag3PO4 plus HNO3 concentrated. We heat it, we get the formation of this AgNO3, 3 molecules, plus we'll be getting the formation of, we have got phosphate, we'll be getting the formation of H3PO4, which is known as orthophosphoric acid, and both these are soluble in water. So yellow precipitate with silver nitrate, which is soluble in HNO3, consider HNO3, or it is soluble in ammonium hydroxide also, that confirms the phosphate. So this was silver nitrate test. Now second test for phosphate is magnesia mixture test. Magnesia mixture test. What this magnesia mixture is? Magnesia mixture is an equivolume solution of magnesium chloride or magnesium sulfate plus ammonium chloride, and this is then in the presence of ammonium hydroxide. This solution is known as magnesia mixture. So this magnesia mixture is added to the soda extract containing phosphate. Let us say we have got this Na2HPO4. This is sodium hydrogen phosphate. Plus we add magnesium chloride plus ammonium chloride. We get the formation of magnesium ammonium phosphate, plus of course we'll be getting formation of NaCl. We take 2 NaCl, and this is a white precipitate or milkiness. So test is that to the soda extract which has been neutralized with acetic acid, we add magnesia mixture solution and we get white precipitate or milkiness. You know, in books it is written that you add this solution into it and you scratch the inner walls of the test tube, and the milkiness or say whitish color, whitish sort of appearance, a solution will become whitish. This is due to the thing that sometimes this precipitation process is slow, and with the help of scratching of the inner walls of the test tube, we create active sites which encourage the formation of precipitate. So then milkiness appears a bit readily as compared to the case when we don't scratch the inner walls of the test tube. So this was second test. And then another test which is commonly performed for phosphate is, that is ammonium molybdate test. This is ammonium molybdate test. What this test is? We take soda extract, we add concentrated HNO3 to it, we heat it, boil it, then we add ammonium molybdate solution to it and reheat. The appearance of yellow precipitate indicates the presence of phosphate. I'll be writing the balanced chemical equation for this. Suppose we have got sodium phosphate, we add ammonium molybdate to it. I'll be writing balanced equation, plus 24HNO3. We heat it, we get the formation of, this is ammonium phosphate dot 12 MOO3, 6 water molecules. This is known as ammonium phosphomolybdate. Ammonium phosphomolybdate, and it is yellow in color. Plus of course we'll be getting say 21 ammonium nitrate plus 3 sodium nitrate plus 6 water molecules also. So main thing is that we get the formation of this ammonium phosphomolybdate compound which has got yellow color. So test is that soda extract is boiled with concentrated HNO3 followed by the addition of a few 1 or 2 milliliters of ammonium molybdate. We reheated the solution again and we get the formation of yellow precipitate of ammonium phosphomolybdate, indicating the conformation of phosphate. And last of all, we come to the borate. Again, there's a very beautiful test for this, which is known as a green edged flame test. So, number one is green edged flame test. What this test is, we take salt mixture, we add about 2 milliliter of ethyl alcohol to it, and then about 1 milliliter of concentrated H2SO4, and we heat it strongly. What happens? Suppose we have got this sodium borate. We treat this with H2SO4. We get the formation of 2H3BO3 plus, of course, 3 Na2SO4, 3 molecules of this, plus of course some water will be formed. This is boric acid or orthoboric acid. This boric acid, when treated with ethyl alcohol, and we heat it, we get the formation of this is ethyl borate or triethyl borate. Now, when we heat the contents of the test tube, in the test tube, then vapors are coming out. Those vapors at the mouth of the test tube, we ignite those vapors. Then, at the mouth of the test tube, I'll just show you. We get this sort of flame, and in this flame, outer edge of this flame is green. That's why this test is known as green edged flame test. You see what happens? We have added here ethyl alcohol. Ethyl alcohol, you know, it is spirit. When you burn it, then bluish yellowish, with bluish or yellowish flame it burns. But when we perform this test, we convert borate into boric acid and then boric acid into ethyl borate, which is more volatile than spirit. Then when the vapors are coming out, then at the outer edge we have got ethyl borate. When we ignite this, this burns with green flame and this burns with yellow or bluish flame sort of. So this is green edged flame test for borate. And there is another test also, that is turmeric paper test. Turmeric paper test. All of you know what is turmeric. So in this case, the salt solution is prepared in dilute HCl, and in that we dip a turmeric paper into it, and then that paper is taken out, and then this paper is wrapped around a test tube, and this test tube is heated. This paper dries up, and then after dried paper, this is again touched with a drop of sodium hydroxide. So that spot where we touch the turmeric paper with sodium hydroxide, that turns bluish or greenish black, indicating thereby the presence of borate. So as I mentioned earlier, that we are not going for arsenite, arsenate and chromate, etc. These are the basic radicals, that is sulfate, phosphate and borate, which we generally come across during analysis in the preliminary stages. So I hope if you just go through this account, then this will make you understand the things easily regarding these tests. So this was in continuation of the acid radicals. With this, we finish the account of conformation of acid radicals, and in the coming lectures on the topic, we'll be discussing basic radicals, preliminary tests and basic radicals, and so on. So thank you very much for patience for listening to this lecture. Thank you.